continuing with this equation can now be rearranged to find this g by t, because in the last formula we need to find this, in this last expression in equation 1 we need to find del t by del g, which we have found over here, this one, and we again need to find g by t, and finally we have to substitute those two expressions, one at here del t by del g and another on g by t. So g by t is 1 plus gh. Now after substitution, 1 by 1 plus gh whole square into 1 by 1 plus gh, we are getting sensitivity as 1 by 1 plus gh. So therefore, now how can we explain the term sensitivity? It is 1 by 1 plus gh. That means sensitivity of the overall gain of the closed loop system is the reciprocal of 1 plus gh term. So 1 plus gh term is a very important term while explaining the effect of gain or effect of feedback on gain or effect of feedback on sensitivity. This 1 plus gh term is everywhere so important. So therefore, the sensitivity getting this 1 by 1 plus gh, we can say S is equal to, if it is 1 by 1 plus gh, that means the sensitivity is reduced or increased. It may increase or decrease depending on the value of 1 plus gh. Now how the dependence of this 1 plus gh we will understand. Two cases may arise. One is 1 plus gh is less than 1 and another is greater than 1. Similarly, what we have seen while explaining the effect of feedback on gain, the same explanation will be applied over here. Once this 1 plus gh is less than 1, that means this gh value is negative and gain in the feedback path is negative, and when it is greater than 1, gh value is positive and gain in the feedback path is positive. So in general, gh are once again we are emphasizing that they are the function of frequency. So feedback will, within some frequency range, feedback will increase the sensitivity of the system gain, while this 1 plus gh is less than 0, and in some frequency ranges, similarly what we have seen in the case of gain, effect of feedback on gain, the same thing happens over here in some of the frequency, some other frequency ranges. When this 1 plus gh is less than 0, that means sensitivity is increased, and when it is greater than 0, the sensitivity is decreased. So therefore, if the whole frequency range is segregated in that fashion, so therefore we have to choose the values of gh in such a way, that means the values of gh means the value of loop gain, that means the choosing of the value of the feedback sensor, that means its gain, that is h, through which we can control this value of gh, or by selecting the particular process gain g in such a way that the system is either insensitive or less sensitive to parameter variations. That is the main idea, because if it is oversensitive, then it may create some difficulty in running the system. So therefore, the idea is we should select this g and h in such a way that the system is insensitive or less sensitive to parameter variations using this analysis. Now, this sensitivity analysis is based on the closed loop system, but while we are using the open loop system, you all know that there is no feedback in the open loop system, so h is equal to 0, and if we analyze the sensitivity for an open loop system, then S of t with respect to g, you can see that it is 1. Why? Because sensitivity is 1 by 1 plus gh, and if h is equal to 0, then S is equal to 1. And what does it mean? The overall gain of the system t will be varying, will be relying, will be changing in 1:1 fashion to the variation in g. That means whatever variation in G happens, the similar way it will T will follow it. So sensitivity of T with respect to H, the feedback sensor is given as this. In the similar way, if we can derive now sensitivity of T with respect to H, previous it was with respect to G. Now if we derive with respect to H, we can see in the same way how we have calculated this S equal to 1 by 1 plus GH. In the same manner we can get this STH is minus GH divided by 1 plus GH. So therefore, for large, now if we analyze this one also, for large values of GH, sensitivity, if GH is large, then sensitivity of the system with feedback with respect to H approaches unity. That means in that case, this 1 can be neglected with respect to GH, and GH will get cancelled, and this STH will be equal to 1. So sensitivity will be 1. So therefore, for large values of SH approaches, that means sensitivity of the system with respect to feedback path gain approaches unity. Thus, changes in H, what does it mean? The changes in H directly affects the system output. So it is far more poor for the system, far more dangerous for the system, because it directly affects the system response, while in case of G, it was 1 by 1 plus GH, but here it is 1. So for sensitivity analysis with respect to H rather than G, it is far more dangerous, far more difficult to explain, far more difficult to run the system with respect to this sensitivity analysis with respect to this H while we are doing this sensitivity. So therefore, it is important to use the feedback which do not vary with environmental changes, because environmental change will directly impact the value of H, and once it happens, if we do the sensitivity analysis at that time with respect to H, it will come as 1, and that is not very good thing for the working of the system. Now therefore, the optimization of the sensitivity by feedback with system gain can be achieved. So finally, seeing these different cases of sensitivity analysis, we need to optimize the sensitivity while using the feedback in a control system in terms of system with respect to system gain.